Hi, my name is Ben Jones, and I am from Tennessee Tech University.
Hi, my name is
My
Ben
topic
Jones,
is
and
on
I am from
electricity
Tennessee
and
Tech
magnetism in
University.
the future of transportation.
My topic is on electricity and magnetism.
To start out, from first implementing animals that live among us with the horse and carriage to using a wider knowledge of steam and fossil fuels, the power sources of transportation are continually evolving, as seen in our usage of planes, trains, and automobiles. As human knowledge of the physical world has continually progressed, the tools we utilize as a species have advanced in tandem. Yet the places we occupy are growing and require faster ways to get from point A to point B, and fossil fuels will eventually go down in supply. With necessity being the mother of invention, the prospect of utilizing old technology and better energy in the form of electricity and magnetism is becoming more appealing to consumers in regards to environmental impact, efficiency, and cost. Possible solutions. Despite their common use, fossil fuels have a disadvantage of emitting harmful gases to the environment during combustion inside a vehicle. This has led multiple environmentalists and scientists to push for reduced emissions by decreasing the amount of individuals using these vehicles and or using vehicles with different fuel sources. As a result, this has encouraged experts in energy to assemble lighter ultracapacitors so as to replace current lead acid batteries, which are heavier and have one-tenth the energy capacity in comparison. Continuous development of permanent magnet-powered motors is also underway, as these would have less impact on the environment. Fuel cells are another considered power source, as they produce electricity from chemical reactions similar to a battery. Yet while a battery has chemicals stored inside, fuel cells have an external supply. The advantage of fuel cells is that they produce more power in a smaller amount of time. While not totally in common usage by the world populace, these increasingly newer utilizations of electricity and magnetism are slowly but surely gaining momentum, as seen in new trains and cars, and have the potential to shape the future going forward. I'm going to start out with electricity and magnetism in trains. Electric trains work by having an electric motor that is powered from a receiver that is in contact with an electricity supplying wire that is parallel to the train. Most of these electric trains are run at a decreased cost and accelerate faster compared to trains that run on fossil fuels. Maglev trains. Maglev trains, also known as magnetic levitation trains, stand out in the use of electromagnetic technology and are being developed currently. As the name implies, these trains rely on the principles of electromagnetism so as to levitate and propel a train along its track in contrast to using wheels. Utilizing this concept has the desired goal of not having friction between wheels and a track, and ultimately would allow a train to travel at much faster speeds with the highest recorded speed of 603 kilometers per hour currently. Specifically, these trains are accelerated and slowed down by a traveling magnetic field instead of motors. This involves three components specifically: a large electrical power source, metal coils lining a guideway or track, and large guidance magnets attached to the train's underside. Currently, some maglev trains are being used in China and South Korea, but they are operating at slower speeds and are not open commercially. Additionally, the United States is considering implementing this technology, but money seems to be the biggest problem. With costs estimated to be roughly $150 billion, it may be a while until progress is made in the United States. However, there is hope that with the common utilization of this technology in the future, it will provide a cheaper alternative to vehicles that use fossil fuels. I'm going to shift gears to hybrid cars as a segue to fully electric cars later. The application of cars being powered by electricity is not a foreign concept, but does seem to be one that is gaining a wider consumer market in recent years. Hybrid cars have been on the market for quite some time, relatively speaking, and combine both aspects of a gasoline engine and a secondary electric motor system. Additionally, they are suited with a pack of rechargeable batteries as well. Generally, traditional vehicles have an internal combustion engine powered by diesel or gasoline. Hybrid cars are also fueled by gasoline and utilize internal combustion engines, but the difference lies in the fact that hybrid cars can be partially or completely powered by electricity. These cars employ regenerative braking technology, which converts the mechanical energy produced from braking to electrical energy and stores it back into the battery for future use. Advances in these vehicles have led to more upscale hybrids containing large batteries that can be charged from electrical outlets, allowing an extension of the miles driven on electricity before being switched back to gas power. As a result, hybrid vehicles are more fuel and cost efficient. Few toxic gases are released as well, making them better for the environment in contrast to traditional vehicles. Overall, hybrid cars utilize the power and range of traditional vehicles as well as the ecological benefits of an electric motor. Yet, as time moves forward, more advances are being made in cars implementing electrical technology. Switching gears to electric cars. Recently, more cars powered only by electricity are slowly but surely gaining traction in the automotive market. These vehicles differ from others in the fact that they have rechargeable batteries inside not just to power the car, but allow the functional use of lights and wipers and other functions as well. This results in electrical vehicles having more batteries in contrast to traditional vehicles which only have one. These batteries utilized by electrical vehicles are the same kind that are used to start up a traditional gasoline engine, but the difference is that a number of these batteries are powering the vehicle's engine. Since these cars are powered solely by electricity, no gas is required, which has the added benefit of being cheaper, allowing the average American to save anywhere from $2,000 to $4,000 on gas each year. As mentioned earlier, with electricity being a cleaner energy source, electrical vehicles are 100% eco-friendly. These cars also do not require much maintenance as there is no need to lubricate electrically powered engines. Additionally, one could even say that the quietness of electrical vehicles is a benefit as they reduce noise pollution. In the present, there are some disadvantages and flaws that still need to be worked on for these new vehicles. For instance, electric fueling stations are still in the stages of development, resulting in few locations having places to charge these vehicles. Charging a car is also an inconvenience, as it takes approximately 4 to 6 hours to fully charge and fuel a car, in contrast to traditional vehicles being fueled in minutes. This disadvantage should also be taken into consideration if one is charging from home, as electricity is not free and could add to one's energy bill if one is not properly researched investing in an electric car. Another disadvantage is most electric cars in the present time are also somewhat small and have a short range of about 50 to 100 miles before needing to be recharged again. Finally, while there would be less maintenance than a traditional car, electric cars require a battery replacement every 3 to 10 years, depending on the model. Despite these shortcomings, recent evidence has shown that electric cars are cheaper to own in the long run and would suggest that we will be seeing more electric cars in the near future. The aforementioned disadvantages seem to be more so because there's just not enough research and not enough development and use of electric cars in the present time. Other uses for electric transportation. While electric cars and trains are in the forefront for common usage of electric vehicles, other manufacturers, engineers, and enthusiasts are taking the concept of electric and magnetic energy and applying it to other forms of transportation. For instance, NASA has been researching the potential of maglev technology to launch spacecraft into low Earth orbits with its high speeds, proposed as StarTram. Like maglev trains, these spacecrafts would be launched by an electric catapult, where a mass driver would act like a coil gun to magnetically accelerate and decelerate a magnetized holder with a payload. While it would be a major step in space travel and research, a developer of the system, Dr. James Powell, stated, "It's something we can't do now because it's too expensive." Electric bikes are also making a name for themselves as a cleaner way to travel and progress toward a more sustainable future. A concept known as the e-bike was recently unveiled by Ford, which would allow someone to fold said bike and be able to have a speeder commute with more convenience. Recently, a biking company known as Delfast revealed that their new electric bike has a range of 220 miles without the use of pedals, showing just how much electric bikes are advancing. Finally, it appears that even skateboards are going electric, as more products, such as monolith skateboards, are using what's called electric hub motors located in the rear two wheels. Overall, there appears to be no telling of how much electricity and magnetism will be implemented in other forms of transportation. In conclusion, ultimately, making the conversion from vehicles that use fossil fuels to vehicles that use electricity and magnetism will not be easy, but will be necessary as time goes on. As gas dwindles in supply or goes up in price, there will always be a need to search for cheaper fuel sources. In conjunction with this, the price to pay for more fuel emissions will be more difficult to handle. Luckily, new vehicles are being developed or researched, showing that electricity and magnetism as a power source is more plentiful, efficient, cost effective, and better for the Earth's environment. Truly, the future of transportation lies in the utilization of electricity and magnetism. And these are my references. Thank you so much. This has been Benjamin Jones again from Tennessee Tech University. Thank you.